not doing anything new today.
Oh yeah, we went to chapter 6 and then back to 5 point something.
Uh-huh.
5.6 took forever.
Yeah, well, I don't even know when the date was that we did this. Long
It
time
was
ago.
during Spain.
Was it?
Yeah, it was March 9th, 10th, 11th, 12th. Holy Hannah.
Okay. Well, anyway.
Steven, I'm looking at 6.3 and I don't know
6.1 was Riemann sums. This was like 6.1 and 2.
Like the L-ran thing.
Yeah, where you had a function. We wanted to find the area between the curve and the x-axis. And there was like 4 different ways. You could do the left, the right,
Oh, yeah.
middle, and the most accurate was the trapezoid. Remember how to do those or need an example?
We know.
good.
Jeanette?
Trapezoid.
Trapezoid? That'd be like, give me a function that's easy.
X squared minus 3.
Okay,
X.
let's say we want to find x squared minus 3. There's our function. Well, that's just a parabola that starts down here at -3, right? And what do we want to? Where do we want to find the area? Between what? Give me some x values.
0 and 5. 9.
You're not making this easy.
I don't know
Well,
what
we don't
you...
know
Oh.
what behind problem.
Yeah.
That's why you're the teacher.
Let's go
Thanks
from
for telling
like.
my little kids. I'm the teacher, you have to shut up. I do. Don't listen.
This is bad. I should have just made it up.
Yeah, just go.
Try this again.
Trust me.
Yeah, like,
I was like, well, we could do this, and I'm like sitting there thinking about it. I'm like, well, this was supposed to be just an easy example to get your brain going, not difficult.
a foot and a half.
So let's say it's just x squared.
I like those.
And we want to find the area under the curve between 0 and
12.
6.
Okay.
Why did it go so high?
I don't know.
We're going to use the trapezoid approximation method because we don't remember how to do actual integrals, which you probably,
Yeah, so you do base 1 plus base 2 times the length.
sometimes a picture helps. Yeah, and then how do you find the area of a trapezoid?
Base 1 plus base 2.
Times the height times, it's 1/2 height times base 1 plus base 2. And so if you draw your picture and you get a bunch of trapezoids, you have 2 endpoints. So you have, the first one's a triangle, but then the rest will be actual trapezoids. Right? And if you draw, we need to know the dimensions of the trapezoids. Don't we know the heights of all of them because they're tilted up? What are the heights? 1. Yeah, then so we just need the bases. So that's these y values. So we can plug in 1 for x, you get 1, plug in 2 for x, and 4.
Do we take a quiz on this?
Yeah,
Yeah.
that would be 9,
I felt really confident and then I bombed it.
16,
I
25,
don't think I've ever felt so confident on this before.
will be at 36. And so we just do the area of all the trapezoids and add them all up pretty much, right?
Yeah.
And so that would be like, we figured out we could just put a half on the outside, and we could just put the height on the outside because they all have that in common. It's like factoring it out. And then, remember this, on the trapezoid one, it's like, oh, for this first one, you have 0 and 1, so that's 0 plus 1. But aren't we going to use the 1 twice? Remember, this was like the shortcut way.
And then times it by 2.
Yeah, so you had all of these multiplied by 2. So you'd have 1, and then 4, and then 9, and then on and on, 16, and 25.
You haven't put them in the grade book yet? Our test?
Oh, not quite. I haven't graded the ship problem.
Hey, was mine really bad?
I haven't graded the ship
Oh.
problem. That's the only one I haven't. I've done the rest of all the tests. Pedro, you're a beast. Love you, Pedro. You're the only one to get one of the questions right.
Stupid stupid service area one?
The stupid box one, yes.
Yes, that was stupid. I didn't even put an answer.
It's the only one we get it right.
I haven't got my letter.
So yeah, you would do that, you'd calculate it, I don't know what it is, who cares? Remember? Yeah. Alright, that was Riemann's sums, and that was just the way of approximating area. Then we went on to start talking about integrals, which we could find the actual area. Remember I showed you the
Oh yeah, you
shortcut
wrote it
already?
out.
I was like, if you had 0 to 6, remember what this means?
Yeah, you put 6.
It's basically
Into
it's
the
this
thing.
exact problem we just did. It's just find the integral from 0 to 6 of x squared dx.
So you do like 36 minus 0, right?
Close, but no, you gotta do something else first.
Oh, the gx, which is what? No, 1/2? I don't know.
No, you gotta go backwards.
Oh, the antiderivative.
You do the antiderivative, and then you plug in.
6. Or
Maybe we need to talk more. You guys are looking like you
Yeah, I
don't
don't
know
remember
this.
this part.
this is the hand. This is handwriting it out, right?
Let's go back.
I don't think I had this journal when we were all of
I remember watching
It was the
that.
antiderivative.
And then you want a straight line.
Because I remember we just talked about like the train problem. That's like the train's going 75 miles per hour from 7 to 9 p.m. And we're like, how far did it go? We're like, oh, 150 miles. And then we figured out the area of that was 150 miles. So it was like the antiderivative, which is also called an integral, is pretty close to the same thing as the area underneath the curve. So you do the antiderivative and then you plug in those points. I showed you why it works.
But then we were like, what about C? And you want to know C?
Oh yeah, I remember that.
Yeah, and you're like, I don't know why, but I'll figure it out.
Yeah, and then I think that's like the last day we did this.
Yeah.
Because I never looked it up. That wasn't why. Yeah.
So you do the antiderivative.
You do the antiderivative.
The bottom one minus the top one.
And then yeah, you plug in 6 and plug in 0, so it'd be 1/3
Or top minus the
times
bottom.
6 to the third minus 1/3 times 0 to the third,
Which is 0.
which
Oh, that's
is
better.
216 over 3 is 72. So the area under that curve would be 72. Whatever the units are. Remember that, kind of?
Yes.
Yes.
Did you give us these tests back?
He doesn't
What's
do
this?
anything back.
We took it, but I mean, like, when I looked at the test, I can't remember.
You're going to get much stuff back tomorrow, or whatever.
I study off of my
Heidi
quiz.
decides to take her test.
I won't be here tomorrow. I'll be here half the period. Baseball leaves really
Take it
early.
next year.
What?
Take it next year.
Yeah, I think so. I'll try it. I'm just posting from now. I'll try it again next year. We had mean values of functions.
Dude, can I see your baby?
If there was a picture of it, you could.
Why don't you take
Can you show us an update picture tomorrow?
Yeah.
I want to see his Mufasa hair.
Yeah.
It's kind of starting to finally go down. It's too,
Aw.
it's too long.
He reminds me of the little gorilla off the Tarzan. He's so cute.
Like a rich baby.
What about, oh, you remember you guys liked these ones?
We actually liked something?
Yeah.
Are you sure?
I'm positive.
Which is your favorite class
Watch, it's
ever?
gonna be something terrible.
Okay, never mind. No, this isn't the one you like.
Yeah.
But I'll get there. It's on the
I was
list.
gonna say.
It's on the list of stuff to talk about.
Oh my gosh.
For right now, like one of your homework problems that you're about to get today, so we're back to that, is this is 6.2, number 13. 2 to 4. This was supposed to be before you knew that it was the antiderivative, before you knew the little trick. This problem asks you to use the graph of the integrand, big fancy name for that part. Use the graph of that and area to calculate the integral. So you'd have to draw a graph and then calculate areas. So, you know,
With the trapezoid
who
or
could
level.
graph that? No, just straight up watch, you'll see. Who could graph that?
You can.
So could you, Heidi? So oh,
I don't remember what graph that is actually.
no.
Is it?
Is it a
Is
sprinkler?
it the? That's a square root.
Oh no.
It's just a normal graph, isn't it? Isn't that just
A normal graph, I don't know a normal graph.
If the y-intercept.
Oh, line.
So the intercept's at 3 and you
The
go up,
y-intercept
Yeah.
is 3.
go up 1/2.
There we go. Whew.
Good job, Izzy.
It's because you give us these, like, me no complicated ones, then you give us these, and we're like,
We don't know how to do simple. Always complicated.
Sure. Do I need
Hey,
to?
she's not lying. For the longest time, I forgot how to do
Why
like
is it like
addition problems.
Because it's just the
we
line.
had, like,
It's 1/2 x plus 3. Y-intercept is 3, up 1/2. It's just a line.
I can't do like.
But all I care about is from
anymore.
-2 to 4 on the
why
x-axis.
can't they just pick a writings? Like
Excuse
if it's
you.
90 cross.
Thanks.
That's all I care about is that part. You know what I'm saying?
Yeah.
Because all you're going from -2 to 4, it says use areas. Ooh, hey, look at what
So
we
you do
have.
trapezoid method.
Yeah, it's a true. No.
No.
You just. But when she says trapezoid method, I think she means break it into little trapezoids. No, that's just one big trapezoid.
Oh, so you can use the trapezoid method with one.
It's just
with one
half
big translate.
the height of it. Well, that'd be this way: 2, 6, and then base 1. That what is that? 1, 2. I think it's 5,
You think?
and that's 2. I know it is. So if I plug in 4 for x, 4 divided by 2 is 2. 2 plus 3 is 5. So that y value is 5 right there. So set 4221 would be your area. Or you could have broken it up into a triangle and a rectangle. That's what you're doing. It's just the area under the curve between those spots. And if we did the actual integral, which you weren't supposed to know yet in this section, that's why it tells you to do it this way. But if you do the actual integral, like do the antiderivative way, it's the antiderivative of that.
1/3 x to the,
You're going to have x squared, right?
yeah, 1/2.
So 2 times this needs to be 1/2.
1/4.
Yeah, 1/4 plus 3x from 4 to -2, -2 to 4. Let's see, hopefully we get 21 here. Plug in 4, so 1/4 times 4 squared plus 3 times 4.
Times 4.
Minus, and then plug in -2. 2 squared plus
4 is 1 and
so that's 16 times the 4th is 4 plus 12. So I got 16 minus 4 times 4 is 1 minus 6 is -5, but I'm subtracting it.
so it's positive.
Adding 5, I get 21. So there's a couple different. When they're simple like that, you can just calculate the area. But if it's a curve, you can't really do that. That's why we have this. That's what this is for, is to do areas under curves. What else? I'll take off average value for tonight. Let's just see if you can do that. Oh, the one I said you liked. That's right. I forgot about that one. It was like this.
I think you're lying.
No, you did.
It's a very proud day for
You're just making it up.
No, because Heidi's like, I could do these. And I was like, hell yeah, let's.
I did that? I said that?
This is 6.3, number 1.
Right now.
We went through all of chapter 6 almost?
We did 6.123. We did it like mixed up. It didn't go in order.
Easy.
Oh, is it when you add them and subtract them and
Yeah.
that stuff? Because we've done it before with easier,
Yeah, it was.
like functions and the g function.
It was the same thing as derivatives. Properties of derivatives. So it had like that. It gave you like a couple integrals of a couple different functions. Told you the answers. And then I would ask, like, on this one, A says find, well, 2 to 2, g of x dx. What would that be?
You sure?
Huh?
I don't.
Because I did
Yeah, I know.
You can't do it.
You're close.
That's 0.
It's 0,
Because it doesn't move.
because it doesn't
Oh,
move.
duh.
So the area
That
for
was the
that is
tricky
0. You could put anything right here. I could have put f of x there. It's still 0. It doesn't matter. B asks, well, let's just start. I'll go 1. I'll make a middle. I'll go
1 to 5 of f of x.
2 to 5. Oops, I didn't draw the thing yet. 2 to 5.
We didn't try
Two.
to put 4 up.
Oh, wait, negative 4 is 6 is 2.
What would that be?
Negative 2?
It's positive 2. 10?
10. It is 10.
6 minus a negative 4 is an addition.
Yeah.
Okay.
And the reason I think about the graph, and I'm thinking
Yeah.
You gotta take that bigger piece.
between 1 and 2, so from 1 to 2, I don't know what it looks like, but I know it's a negative area, so it's somewhere down here, right? There's some negative area down there. And then from 1 to 5, though, if I do the whole thing, I'm going to get 6. So this piece must be bigger than this. So if 1 to 2 is negative 4, and this from 1 to 5 is 6, doesn't that have to be positive 10? So that when I add them up, I get 6.
But it says from 2 to 5, not 1 to 5.
Oh, 2 is right here. That's where that one ends.
Yeah, your graph is confusing.
Oh, it was? This is from 1 to
I'm
2.
like, you're saying from 1 to 5, you're
Gosh,
starting at 2.
I know, I said the wrong words. In my head, it made beautiful sense. Perfect.
You
Not
showed
even-
us like using a number line last time.
I showed you using a number line?
Yeah, like it was like 1 to 2.
I
and
just
then
take
1
the
to
bigger
Right
one
now,
five.
this
and
looks
subtract
really
the
hard
smaller
and
one.
confusing compared to what we were doing 2 seconds ago.
It's the same thing. Look at the area under a curve is negative 4. Remember, if it's below the x-axis, it counts as negative area.
Okay.
That's from 1 to 2. We know that. It told us that. We also know from 1 to 5, the area had to be 6. The total area had to be 6, right? I wrote that out here. I asked from 2 to 5. Well, that's where this one ends and this one begins, right?
Mhm.
So if this is negative 4 and the whole thing has to add up to 6, doesn't that have to be 10?
Or you could just look at it a different way with your numbers.
Yeah, I think that.
Take away your 1 to 2 because you don't need it out of the big one. So you have 6 minus negative 4. Oh, look, positive 10.
Whatever works for you.
You just confused everyone with the graph.
I can do it.
I was
Bro, you need to scribble that out.
I disagree. I still think that's fine. I think we have a subscriber who's some random dude that I don't know. So-and-so has to subscribe to your channel. I was like, oh great, now this is where it starts. This guy's gonna watch it. It's gonna get shared and I'm gonna be famous.
Do your integral from 1 to, oh,
Do what?
never mind, that doesn't make sense. You already have 1 to
It's
5.
5 to 1, g of x.
Negative 6.
No, negative 8.
Oh, 1 to 5.
What?
Oh,
G.
G of, oh, okay, I thought you said.
That's a beautiful G right there. This is in the book. And then you got ones like 1 to 2 of 3 times f of x.
Negative 12.
Yeah. See?
1, 2, negative 14 is 3.
Yes.
3 times whatever that is.
My name is Jeff, freaking Derek. Did you hear about that?
Do you have
Don't
any
want to
words to
right
say?
Yes, you do.
No, I want to learn.
It's not in the.
Hey, I need to get into UW.
You're already
You're
there.
already in.
You're
You
gonna
can't
take
have
away
us
my
at 2.7.
acceptance.
This isn't going to make you us at 2.7.
Jeanette.
I'm more worried about the griddle. Okay?
A griddle?
Yes, I need to make pancakes and eggs.
Oh my gosh. If that's your biggest worry in life, you guys are just great.
Life is going so well.
You're gonna hit it hard.
That's what people Chris says. In Seattle, you need waffles.
Yeah, does your bed fit 2 people, Andra?
You can.
Because when I come visit you, I am not sleeping on the floor.
You can take it.
There you go. Enjoy yourselves.
Or you can just come